Hello everyone, and welcome to Tracking Yield and Waste in Food Production using Digital Records. Today's presentation will be 20 minutes, followed by 10 minutes of Q&A with Dr. Brady Carter, Senior Research Scientist here at Meter Group. If you have a question for Dr. Carter, type it into the questions pane at any time during the webinar. We'll be keeping track of these to ask during the Q&A. So please don't be shy and submit those questions. We'll also be sending out a link to the on-demand webinar, as well as the slides for you to review as soon as they're available. So, without further ado, I'll hand the microphone to Dr. Brady Carter.
Hello, everybody, and welcome to the virtual seminar this morning. Today I'm going to discuss the idea of yield and waste and how Meter might be able to offer some solutions that could help with tracking these very important assessments of the production process. And so hopefully that will be the outcome of our virtual seminar, and it will be beneficial to you. So thanks again for joining us. Now, a little background information on Meter. We make the Aqualab water activity instrument, considered the best in the world. We've been the world leaders in water activity for many years now. And of course, our instruments, they work great. They do a very good job of measuring water activity. But we've often wondered, what more could we do for our customers rather than just supplying them with a number on a screen? And we've made a lot of efforts to try and help people understand what that value means. But we asked ourselves, could we do more for our clients to increase the profitability of their business and be able to offer additional solutions and more information beyond just that number on the screen. And so with that in mind, we're going to discuss today some ways that we think that we might be able to assist you in improving your production yield. And really, production yield, and the reason why this, of course, is measured is because it's an effective way to assess the profitability of any kind of production, of a production facility. And the key here is to, in an effort to try and optimize the production process, the key is to try and find sources of variability, and especially uncontrolled sources of variability, and see if it's possible to link those up to things that can be controlled, like oven temp and belt speed. Are there things that can be controlled within the process, the production process, that can help to eliminate some of these unexpected changes or unexpected losses that can occur during the production process? And so when we talk about yield, of course, at its most simple, what we're talking about is what percentage of what you start with in terms of your raw product, including all ingredients that go into a lot of a product that's going to be made, how much of that is actually shipped out as finished product. Because, of course, the revenue comes from the product that's shipped out based upon however that's sold, which is typically sold on a weight basis. And so production yield is a way to measure the efficiency and the effectiveness of the production system. And it's a way to be able to assess whether or not changes or attempts to try and improve that effectiveness and efficiency are actually working. Are they making a difference? Are they actually translating into more profitability and more revenue? And so the purpose in trying to track yield is to really try to identify which of the steps of the production process are really responsible for where the losses are occurring. Is it possible to identify a particular section of the production process that's really the contributing factor? And that could be a lot of different things. And so how can you effectively try to find that? And that's really what we're going to talk about, is the key factors in being able to do that. And so in the end, what it will allow is for you to, a way for a company to be able to assess their profit, um, and their net profit, or their profit, in the sense of how much did they pay for raw ingredients, how much did they pay for the production process, versus how much did they actually ship out and make revenue on. Now the calculation for yield, and this again is true yield. In other words, accounting for all of the potential places where materials or ingredients could go, can actually be quite complex, um, and requires, at its core, the ability to be able to link the identity of a product or a step in the production process to its origins. In other words, how much did you start with in a lot, and where did everything from that lot go, or batch, where did it go in terms of the production process? And that can get quite complex, and in fact so complex that in a lot of cases, most companies will probably just do it based on inventory of ingredients in and products shipped out as a rough estimate of what the yield is. And of course that does give some idea about how well the system's running and how effective the company is, but it doesn't really provide any information about why the yields are what they are, or and possibly even more important, what the yields could be. Because under that scenario, you sort of have to assume that whatever the yield is that you're getting represents what you can actually get, not what you could get. And so the key here is to try and identify how much better could the process be? How much more could your yield be if you were able to track very carefully where everything's going, and be able to account for as much of the loss as you can, while there still will be unaccountable loss. The more you can account for where the loss is happening, the better positioned you are to be able to make changes that can actually make a difference. So in our flow chart that you see here, so we start off with some raw ingredients. They're going to be combined and mixed together typically. And a lot of times one of those ingredients, or most times one of those ingredients, is water. And so water is going to be added into to those raw ingredients. And then the processing is typically, its whole purpose is to get that water back out, as well as there's reactions that occur, and changes to the product itself to make it into the product that you expect. But most of that processing in terms of loss comes from the elimination or evaporation of water through either baking or through drying. And so with that in mind, in order for you to maximize your yield, the only thing that you want to have lost from through the production process is that water, and the right amount of water. And that's key. Not just that you remove that water, but that you remove the optimal amount, because water is weight, and it's a very inexpensive ingredient. And so you want to always, in every case, maximize the water that's left into the product, but still gives the product the quality that it needs and the safety that it needs. And so if we track this processing, you can see that even in this case, most of you would probably think this is quite a simplified approach. But when you, for the purposes of seeing the complexity of trying to track this, if you just think about a batch of raw ingredients going into a production line, there's initially the possibility of it being split, the same sort of formulation being used to make possibly two different shapes of products or color of products. And then from there, you may even go into two production lines, one that creates a larger bag of product versus a smaller bag of product. And so immediately all of this stuff needs to be, or hold its identity. It came from that original batch of raw ingredients, batch A we would call it. And we need to be able to track everywhere that batch A goes. in order to be able to understand where product is moving to, where losses are occurring. So for instance, we need to know the final weight of product 1 shipped, product 2 shipped, product 3 shipped, product 4 shipped. We need to track the amount of batch A that went into rework, the amount of that went into scrap and had to be sold at a lower price. And we need to know and track the amount of that rework product that gets sent out. In a lot of cases, the rework doesn't get run separately. It just gets put back into the production line. And so in order to be able to fully understand the system, the requirement is to have to lock in the identity of this material as it moves through the system so that we know where it's linked back to. That way our yield calculation is actually based upon the actual batch ingredients used, as well as where that or the product that was shipped that came from that batch. And as we are careful about tracking that information as we go, the better suited we are to do an assessment of the effectiveness of the processing. And we can do that through something called a batch score, which is basically the idea is if you were to do the optimal production, the best that is possible, such that the only loss that's occurring is water loss, then you get a grade of 100%. Every time that something happens that takes away from that, it deducts from that score, whether it be because you have to rework or because product goes into scrap and is lost, or if it's because you don't process to the right water activity. And all that can be factored in to determine how effective is the production process, and even what is the source of any failures that are occurring, and is it any changes you make, have they been successful? So how do you do that? So you can see that based on those calculations in the previous slide, it's going to get pretty complex pretty fast. And trying to keep that identity straight using written records is pretty much impossible. It's just too much to do when you got to do all kinds of other things. And so really the key to being able to make this work is the availability of annotated digital records, where the system makes a unique identifier for all of the material leaving from one batch of raw ingredients. And that's very easy for the computer to do, and it can track it and put everything where it needs to be so that you don't have to try and do that through either Excel or through written records. Each weight that's taken, each measurement that's taken is given a unique ID and tagged to that particular batch. So it's the source, the traceability is kept throughout the process. And to be able to do that, you need a system that can do that, and that is what we are introducing as the SKALA system. This is a product that's new to Meter, and its purpose is just what we described. It's to take digital records and put them where they need to be. And what's unique about it is that it can capture that information off of multiple devices, such that you don't have to manually enter anything. It's actually real-time capturing data coming off a range of instruments, from the QA lab, like a water activity meter, all the way to the production line, where it's taking information off of a check weigher or a metal detector or a temperature probe being used in the production process. And so because it's doing this digitally, all the users or the production people have to do is give it the information. They have to run the test, but that's all they have to do is just run the test. It's already been identified in the system to which batch it belongs. The system then collects it, holds it, keeps it all organized, and then at the end, when you want to do determinations of yield or batch score, the system just does that automatically and can even update it real time. So the SKALA system makes it possible to be able to have all of these calculations done that are needed to assess the effectiveness of the production process. It tracks all of that, keeps it straight, makes the calculations behind the scenes, and gives you an assessment of how good your production system is. So one of the pieces, and a key piece of making sure that your production process is as effective as possible and that you're maximizing your profitability, is to be able to avoid loss that can occur. And this could be explained loss or unexplained loss, meaning that if you know you've scrapped material and you have to sell at a lower price, that is a loss. And the other thing, though, that often happens is that when people are setting water activity specifications, whether it be for safety or for quality, um, a lot of times those ranges tend to be fairly wide, say maybe from zero point 0.4 to zero point 0.6. But in reality, there is one water activity that is optimal, that can be identified through other work that we can do, as well as maybe based upon your HACCP plan. But there's a very ideal water activity. In a lot of cases, that may be at, say, zero point 0.6 in that range. And if you were only to process the 0.6 water activity, you would maximize the amount of material that you're shipping out and eliminate unnecessary loss of water. Again, your cheapest ingredient. And so one of the main sources of loss can just be not processing to the proper water activity. And we can actually see that and calculate what the consequences are through the use of a moisture absorption isotherm. So how this works is, if you know the isotherm and you know what the optimal final water activity is, you can actually make an estimation of what your actual expected yield should be versus what you actually made, because the isotherm only accounts for water loss to get to that water activity. If there's weight loss in that goes beyond what you would expect in terms of water loss to get to that water activity, any of that additional weight loss is considered as waste. It's loss that is not going to translate into revenue. So where can waste happen? Well, pretty much anywhere along the production process. And sometimes that can be accounted for and sometimes it can't. In order to truly get to what we're calling the batch score and to really identify where problems happen, the key part of this is to track as much as you can of that loss so that you can account for it. So, for instance, if you digitally record the weight of the ingredients going in and the amount of water added, then it's possible to link back to those original values when trying to figure out how to optimize the system. If you can track any product that's lost off the belt and goes into scrap, if you weigh that before you send it out and link it again through the system to the batch that it belongs to, then that's possible to track that and see exactly what contribution that is. If you track your belt speeds in versus your water activities before of the dough, before the oven and after the oven, then it's possible to figure out what overprocessing is doing, and then make arrangements to fix that through changes in the oven temperature based upon water activity. Using a check weigher that captures all that data is a great way to figure out if you're having over packaging issues, where you're selling product for free. So all that's critical to being able to get at this value of waste. So the key thing here is to track carefully the measurements and the values that are associated with each step of the production process. So it may mean that you have to start weighing a bucket of or a barrel of scrap that's been put off from a batch and then linking it in the system to that batch so that you know when those values are changing and when you're having an effect through any changes you're made. And of course, capturing the water activity and the isotherms is very important. When we talk about isotherms, we dedicate complete training sessions to isotherms. And so if you're interested in learning more, certainly there are resources. But basically, it's the water activity to moisture content relationship, which is unique to every type of product. We have to identify and measure it for every type of product. Once it's known, though, then we can create a model or an equation that will allow us to plug in any water activity and get the moisture content at that water activity. And so with that equation in place, we can give it any water activity, like the ideal water activity. It will then tell us what the moisture content of the finished product should be, versus if you went to a different water activity, what percentage of change in weight would you have because of that extra water loss. And so this all comes together with these calculations. Again, this is, as you can see, it's very complex, but the good news again is that with the SKALA system, all of this calculation, all the calculation work for yield, for waste, for batch score, all done in the background, done by the system. You just need to give it the information. You do need to run the test, and you need to identify the batch. Beyond that, the system does everything else. So that really is the value of having a SKALA system. It can make it possible to do this assessment of production and to make production improvements that just wouldn't be feasible to do if all you had were written documents. And so just as an example, we did a case study on production of potato flakes. Now keep in mind that this was on a very small pilot scale, and so we're scaling that up based upon the results we saw there. The actual results will vary based upon what your production process is and how effectively you're doing it now. But the main point is that the potential is there for improvements if we're actually able to track these losses and to figure out using water activity and other moisture absorption isotherms, other tools, to be able to see what the actual yield should be, and versus what the expected yield would be based upon an understanding of the system. And so in this case, when we scaled it up, you may have a raw ingredients of weight of 20,000 pounds. You have a production rate of 20,000 pounds of raw product per hour. Your expected yield would be 5,000 pounds, let's say, if all you were experiencing was water loss. If you only had an actual yield of 3,400 pounds, then that translates into a waste of 1,600 pounds. At $5 per pound price, that's $8,000 of lost revenue per hour, translating into $34 million in lost revenue per year at normal production rates. Again, these numbers are going to vary depending on how effective and good your production system is. But the key here is that you'll never be able to determine that or assess that if you don't have the capability of being able to track it. And this is just an example of the kind of difference that doing the tracking real time can make. This is actual SKALA data from a company taken at right when they first received their SKALA system versus after. And the dotted lines represent the tolerances for water activity. And you can very clearly see the difference that it makes when you're actually tracking those values real time and making real adjustments, process adjustments, true quality control to be able to keep those water activities where they need to be. And so much less cases of not meeting specifications. And so in summary, our goal of trying to go beyond just the number on the screen comes with the introduction of the SKALA system, where we now have the capability of taking those numbers that come off instruments, and we can connect the SKALA to lots of different instruments, not just our own, and collect the data off of those. When that data is collected in that way and then stored digitally, it can easily be annotated, allowing for traceability to make for very careful tracking of where things go, what's going into rework, what's going into scrap, how is loss occurring. And so with that, plus having an understanding of the importance of water activity, the possibility of over-processing that can result in lost revenue, all of that comes together within the SKALA system to give the possibility of having up on a screen within the QA lab or within the production facility where it's showing exactly your efficiency, what is your batch score, how close are you to 100%, and what is your real-time yield. And then every time you make changes, the screen's going to show the result of those changes. So people are able to see real-time the effect of their work, how much they're contributing to the company. And so in that sense, it becomes a very effective tool to be able to take to a next level the ability to optimize and make efficient the production process. And with that, we are finished with the virtual seminar and are ready to take some of your questions. Again, please use the questions tab to answer or to ask your questions. If you have questions that you just don't feel like asking at this point, my contact information is seen there, or you can contact anyone here at Meter for additional information. While you're thinking of we do have a few questions that have come in, and again, as questions come to you, please submit those. So one we have in here is, can you make manual entries into the SKALA system? And the answer to that is yes. You can make manual entries, so it's not just instrumentation. If you have some sort of a measurement that you take that really doesn't lend itself to instrumentation, or if you have an instrument that's not yet connected to SKALA, You can use the system to make manual entries, and then once it's done, then of course it's stored in the system, and that becomes a digital record. So it is possible to do that. Okay, we have another question coming in. The question is about whether or not there's a wireless connection can be made with SKALA with other devices, say through Bluetooth or other types of wireless communication. It is possible to do that with certain types of probes. For instance, with some types of humidity probes that work off of Bluetooth, they can. Most benchtop instruments at this point have to be wired through a USB connection, but there is it's certainly something that we're looking at to make it possible. The challenge with that in any situation, of course, is good communication. And in production facilities, a lot of times there ends up being a lot of blockers to good communication. We've been able to deal with that and overcome them, but in some cases it just ends up being better to wire things up rather than to try and rely on wireless. But to the extent that we can make that work and make it sense and it makes sense within the system, we are making that available. Did have a question come in about a recording of the webinar. There will be a link sent to a recording of the webinar after the webinar is over, as well as access to the slides. It may take a little bit of time afterwards, but that is coming. Another question that's come in is about how do you determine what the ideal water activity is for your production process? And that does require some additional understanding. Sometimes if it's if water activity is say, for instance, a critical control point for your process to avoid any kind of contamination occurring after production, then those values tend to be fairly set by regulations, where you have to be below 8.6 to stop pathogenic bacteria. But in a lot of cases, it ends up being that safety isn't necessarily, at least not after processing, where there's a kill step, and that the baking process makes the water activity lower than, say, 0.7, or where there's just nothing really that spoils, or below 0.6 where nothing grows, where safety isn't necessarily as big of an issue, but then quality becomes very important. And there are optimal water activity ranges for all types of products, where you can minimize the things that could possibly end the shelf life through control of water activity. And that really is the essence of the things, other types of educational materials we provide. For instance, you can go to our website and learn more about what's called Shelf Life Simplified, which discusses the whole concept of how to come to and determine ideal water activity specifications. So I encourage you to visit our website to find out more about that. Another question came in of what type of ports can be supported on instrumentation. We do, for the most part, we have the best luck by far with just a serial port, so an RS-232, and then converting that into a USB connection to go into the SKALA. If the instrument or the measuring device has a computer output, in a lot of cases, we're able to figure out a way to make that work. But the main requirement is that there's a port of some sort on the system, and that it does have the capability of putting out to spitting the data out from the instrument to a computer or similar. So that's really the key. Most types of it ends up most types of instruments and measuring devices do have ports on them that allow for communication. The older, if they're very old, in a lot of cases that may not be the case, but for most types of systems used in production facilities, there is some type of a communication port on the equipment. Okay, so we're we're to the end of our virtual seminar. I want to thank everybody for coming and for your questions. Again, if you would like more information about the SKALA system, please visit our website shown here on the screen at www.metergroup.com, or you can contact us and call us for more information as well. Again, we will be providing a link for recording of the presentation as well as to the slides. And please visit our website to learn about additional upcoming virtual seminars. Thank you for your time and have a great day.